We're going to look at perpetuities and a little bit more on annuities. All right. This time on annuities, we are actually looking at index withdrawal. So basically, on Wednesday, I explained to you. Annuities is something that you put your money in and is investment. For example, a retirement fund. And you actually accumulate interest at a certain time frame. For example, it could be 5% compounded monthly and you're withdrawing monthly so that you can spend the money for your retirement. So it's sort of like a stream of income annuities. All right. So I show you how to do annuities on class bet. Also show you how to do annuities with recurrence interval. So what I want to talk about is the perpetuities. Just understanding what perpetuities are and be able to model perpetuities using sequences and class bet. So we need to be able to solve problems using perpetuities and be able to solve problems involving annuities with index withdrawals. After this, we've got one more topic on Monday, which is the compounding period, and it's different from the payment period. All right? That's about it, and then we'll go on to work on the last topic for year 12. All right. A perpetuity is a type of annuity where regular payments are paid from the investment that continues forever. So think about the word perpetual, think about the word forever. So perpetuities is something that you keep on getting the money. You put the investment in, you're withdrawing the amount which will not decrease your principal. So you keep on getting the same amount. All right, the value of the investment remains unchanged over time. So I did mention that on Wednesday, but I did not give you the exact term, which is perpetuities. The value of the payment per time period is equal to the interest earned on the investment over the time period. So therefore, you are just taking out the interest. You are not taking any part of your investment out. So if you think about it in terms of a model, all right? If this is your principal, you've got interest that is paid every, say, quarterly or every monthly. So situation one, you could be withdrawing something which is more than your interest. So you're withdrawing your interest plus a bit of your principal. So therefore, eventually what will happen is you will not have any more money in that account. Whereas in terms of perpetuity, you are only withdrawing your interest, that's all. During that whatever time period of compounding interest, you are withdrawing that interest. You are not withdrawing anything more than the principal. So for example of a perpetuity is a scholarship which is set up to exist for all time. That's a really good one to think about. So for example, some university or some school, they've got a scholarship fund. What they do is they've got a lump sum, they raise money for a lump sum of money, and the interest is used to pay the scholarship for the school fees. So basically, all you need to think about is Q equals to P times R, which is the principal times the rate of interest per time period, where Q is the value of the regular payment per period. All right? It's basically the principal times the interest. That's it, nothing else. I will show you how to use financial function, but if you've got a question like this, just use Q equals to PR. It is not in your formula sheet, but if you remember something I've drawn here, you're looking at the interest, which is based on the principal. All right? So now, sorry? Yep, no worries. So if it is compounded monthly, so you're just taking up monthly. That's it. The interest is not added to the principal. Right? Let's move on. So, if you use class pad, what happens is principal is entered as a negative value. The future value is no longer zero. It's actually exactly the same as the present value, but it is positive, that's all. Alright? This is what you need to do with if you use your financial function. Again, I have not really need to use a financial function for this sort of question, for perpetuity question. I have always used Q equals to PR. That really avoids the issue of negative and positive. Alright, so basically that is just the interest. Okay, now let's have a look at the example. Jacob has 500,000 to set up a perpetuity for his granddaughter Sophie. He invests the money in bonds that return 3.5% per annum, compounded annually. How much will Sophie receive each year from this investment? It's just basically 500,000 times Q equals PR, 0.035. Using your calculator, 500 times 0.035. So the amount is 175,000. All right. Now, if I want to use class pad, all right, what you need to do is be able to put in your class pad. Let me write down on the board 500,000 and 3.5%. Okay, class pad. Something went wrong with my, let me quickly set this up for, okay. Something is wrong with my ClassPad subscription, so give me 1 second. I know why. I changed my password this morning. I haven't actually updated my password. That's the reason why. Yep, should work now. All right, now I can use, that's better. Let's go to financial. It's under compound interest. Now, we don't know what N is, but we know the interest is 3.5%. The current value is 500,000 and future value is 500,000. All right. What are we going to do with N? Since we don't know what N is, which is the time period. So what we need to do is just put in, because it's going forever, as a long time. Could be 50 years, could be 60 years. It really doesn't matter.
Can you make it 100?
Yeah, you can. You can try making it 100. That's fine. And then tap on that. You see the value doesn't change. So the period has to be long enough. Therefore, the reason I don't normally use the class pad for this sort of question is because Q equals to P, R is the same. Yeah? Why bother going through and typing all this? Yeah. Yeah, I have to give you the example because you do need to know how to use it. All right, that's something that you need to know, and I have to teach. Oops. Yep, that's better. So now, what I've done is I've shown you. So what I need to say here is, it's put in period, which is, let's say, maybe over 15 years. All right. Okay. Just put a long time. That's all. Can you try this question, please? Right? Now, if we use Q equals to PR, you know what Q is, which is $5,000, and R is 0.04. So therefore, P is just basically Q divided by R, which is 5,000 divided by the interest, which is P therefore is 125,000. Pretty straightforward. Now, the next one that we need to look at is index annuities with index withdrawal. When I say index withdrawal, is think about if you put money into your, let's say, superannuation or annuities, and you want to withdraw and you want to live on that. You realize that every year there's an inflation. So you need to think about how much money you need. You cannot be taking out exactly the same amount every year. You have to increase that. So therefore, this is index withdrawal. And using index withdrawal, we actually should use recurrence relation because we can build in the percentage increase every year or every time period. So recurrence relation, I spoke to you about this on Wednesday. It's actually basically an investment because there's interest, compound interest, whatever time period. Take away your withdrawal, whatever money with withdrawal, and you've got an initial investment, and what you want is probably calculate until the time that you don't have any more money in that account. Same sort of situation occur. This time, what we want is increase the withdrawal. Right? Can you please write this down? This is what index withdrawal means. The withdrawal is indexed most likely with CPI, the Consumer Price Index. Or could be the inflation rate, could be whatever you want. Alright? Same formula, we just added this extra bit here. 1 plus percentage increase. Whatever percentage increase you want. One example, and then I'll stop the lesson. And to be honest, I could only find 2 questions for you to do. It's not in cloud. This is basically from Wednesday. This is the addition, index withdrawal. right? Happy for me to move on? Okay, no worries. All right, let's go. Now, example 3. Mary wishes to deposit 200,000 into an account which will earn interest of 8% per annum, compounded annually. She wishes to withdraw 25% at the end of the first year, 25,500 at the end of the second year, and so on and so forth. The withdrawal is 2% increase on the withdrawal of the previous year. So you can see that the index is 2%. All right? 2%. So every year, so 1% is 250, 2% is 500. You can see that. So sometimes what they would do, the question is ask you to calculate the percentage increase as well. Give you several of the percentage, several of the consecutive withdrawal. Then you have to work out the percentage increase. So here, what it says here, what will be the balance of the account immediately after the withdrawal? So we need to write out the recurrence relation. Let's call it Tn plus 1 equals to 1 plus compounded annually is basically 0.08, that's it, times Tn. Take away 1 plus 0.02 because it's 2% to the power of n. 25,000. All right? Yeah? So go back to that. It's T, which is withdrawal, times 1 plus the percentage increase, which is here, the percentage increase times that.
And so n in this case is
So n is, okay, when n is the first withdrawal is here, just equals to 1. This is at the end of the first year, at the end of the second year. All right? And T naught equals to 200,000. All right? Are you all happy with that? So think about it. Tn plus 1, which is, if we use T naught after the first year, we put an increase and we take away 200,000, 250,000. Yep. 25,000 is a withdrawal at the end of the first year. If you read the question, yep.
when you're entering that into a savings function, where n is, are you stating that blank?
Yes, it's the end. All right, I will.
Sorry, what's the n?
N is the number of the year after withdrawal. It's basically the same as this n. Tn plus 1.
Okay.
The third function. All right.
Oh, and you actually input n
And as n. Yeah, that's right. That's right. That's right. I'm pretty sure. Yep, that's correct.
Yeah, makes sense.
Make sense? Sorry, I should have mentioned that. It,
Been made clear now.
yep. So if you do that, we will type it into the class pad, please, into your class pad. Alright, let's put in our class pad. I try to write it down. Class pad. This one will have to be in the recurrence, which is sequence. Alright, so let's do edit clear all. I've got it in front of my screen so that I know this is 1 plus 0.08 times Tn, or which is An in this case, An minus 2500 25,000 times 1.02 to the power of n. See, this is n, where your class pad is, you enter n through there. That is just the term number, that's all. So therefore, that is 200,000. Tap on that, and then let it calculate. So after 5 years, it should be 141679. 141679.25136. State what T5 is and then answer the question. Part B. How long will it take the account to reduce to zero? So I'm going to go straight down to the class pad. So T11 equals to 12884.1791. T12 equals to minus 17169.4442. All right, so it is in the 12th year. It is in the 12th year because you can see that this amount is actually less than 25,000. You can still withdraw some money. Yeah, so therefore it's in the 12th year. So answering question like this, we can say that T5, part A, T5 equals to 141,679 point 25136. Therefore, the balance will be 2 decimal places, 141,679.25. And B, show that T11 equals to 12884.1791. T12 equals to minus 17169.4442. So therefore, the account would reduce to zero in the 12th year. Alright, pretty much it's just a sequence. Sequence, you can take into account the index withdrawal, whereas financial function you can't do that. You can't. Financial function will just give you the consistent payment, that's all. Alright, so if you've got a question like this, you need to use your recurrence relation. Alright, so that's all I have for you today. Basically showing you two concepts. One is a perpetuity, which is Q equals to PR, and the other one is annuities with index withdrawal. Alright, you should have some question in club and 2 extra questions on the index withdrawal to do. All uploaded.